Hi, I'm Jeremy Willette. I'm the Vice President of Project Development for Wolfden Resources. So I just wanted to welcome the Land Use Planning Commission team members out to our Picket Mountain proposed facility or deposit. One of the reasons why we wanted to stop here is because with the bridge here on the roadway, so the roadway in, we do plan on expanding and widening out for two-way traffic, but we wouldn't plan on impacting this bridge. It's designed and built quite well, and it's maintained well, so it's fine. Any questions around this area?
And down that way is, I believe, Tote Road Pond, not too far.
Yeah.
So how far is it from here into Picket Mountain Pond?
So Picket Mountain Pond is about a little bit less than half a mile up the creek bed. This is, I guess, point number 2 on the tour. If you look to the north of the road, this is sort of the eastern edge of the proposed tailings facility. So the tailings is going to be where we deposit the waste from the concentrator process. It's going to be a completely contoured and lined facility. We come in with about 2 feet of compacted till and clay, and then we cover that with a geosynthetic liner. So everything is completely sealed. Any water that contacts it is collected, and it actually goes back through the concentrator as processed water. So we ultimately intend on recycling everything we can and sending it back through the mill. On the south side of the road, we won't go for a walk, but just through the woods here is one of the proposed PDPs, or potential discharge points. So a potential discharge point is when we collect impacted surface water or discharge water from the mine openings. We pump it up into a series of ponds. Those ponds then contain the water, and then that water is treated through a water treatment facility back to at or better than background water quality. So we won't know what that water quality is until we finalize all the base round studies, but at the end of the day, the water that we put back into the environment is going to be the same or better quality than it is currently. The PDPs are there because we have to discharge back into the groundwater, because we're going to be removing this water from precipitation, etc. Typically it seeps back into groundwater. So we can't just deposit it back into the pond through a pipe or anything like that, so we do have to get it back into, and these PDPs are typically, they're essentially just septic fields. So we pump them in, the water spreads throughout them and then dissipates into the groundwater again. Any questions around, I guess, the tailings facility or the PDP? I will mention too, we are going to stop again within the sort of the center of the tailings facility. You'll get a better look at the lay of the land there as well.
Jeremy, how far this way would the tailing management facility extend from this point?
So the tailings facility is it's roughly 2,400 feet long by 800 feet wide. So it's a 90-acre area total that we're going to be looking at for this facility. The idea is that, you know, we'll start by depositing tailings in this area, but we'll break it up into 5 separate cells. So we'll only be operating about 20 acres at a time. And so we'll open up the first 20 acres in this area, so contour it, construct it, deposit tails, and then close it. When we close it, there will be a similar liner. So it's another high-density polyethylene liner that covers over top of it, and a series of graded silts and tills, and then ultimately the organics will go back on top. Once we finish with one cell, i.e. 20 acres, then we move on to cell number 2. And then we close cell number 1, and the idea there is that we only ever have 20 acres roughly of impacted area in the tailings facility.
What's the height of the tailings facility?
So at closure, the maximum height of the tailings facility is anticipated to be 22 feet. We wanted to try and keep it below the tree level. And then the other one too, I guess, after closure, the beautiful thing about the design is that we're able to evaluate how the design has worked and how it's functioning. So if there's any tweaks or anything like that that we need to make sure that we're not seeing any impact to surface or groundwaters or air or anything like that, we can make those tweaks in-house and address them in the early years of the operation. We don't have to wait until the end of the life of mine where we're trying to evaluate these things and find problems. So we can really prove the concept as we go, which is a huge benefit to the operating style.
Do you know if all the tailings are going to be disposed above ground or below?
Yeah, so based on the Chapter 200 legislation, we do have to deposit all of the tailings in a surface dry stack facility. So that's what we've designed for. So basically we're going to be looking at around 800 tons per day roughly of tailings deposition, and all of that will be stored out here. So the process is going to be, when these tailings are coming out of the concentrator, you can imagine they're like a slurry. And we take that slurry, and within the concentrator, we thicken the slurry, and then we filter the slurry. So we drag all of the water out of it down to a low percentage, 8 to 10% moisture. So it's like a thick cake that then we load into a truck and we haul over to the location, the tailings facility. And then we dump that material and then we contour it with a dozer. And then after it's all contoured and graded, then we come with a roller compactor and compact it down nice and tight. So essentially what we're constructing is a brick on top of a line facility. The material that we're depositing, these tailings, are very fine. They're almost like a flour size. So, we're talking, 30 to 50 micrometers. What happens when you have moist flour and you compact it like that, water, precipitation, etc., can't permeate into it. So that's another level of security that we have with the dry stack tailings facility. So even if there's some sort of perforation in the liner after closure, it'll contact the tailings and then shed off. But as we're operating, the tailings will obviously be exposed, but the same thing. The precipitation wouldn't be able to penetrate. It would just hit the surface and then shed off around the sides, and we'll grade it as such. Okay.
When you close a cell in the tailings facility, what does the kind of end product look like?
So the idea is that we try and mimic as close to natural background as we can. Obviously there's going to be a 22-foot bump, but the idea is that we would be grading it so that it looks natural. Okay. After closure, I was mentioning earlier that we'll cap it with organic materials, silts and clays. And as we're stripping the property, we pull the organic materials and we store it. So that when we do close it, we can take that material and spread it back over, and that way we can ensure that similar trees and shrubs and grasses, etc., are all growing back on top. The only thing that I want to avoid upon closure of the tailings is around deep-rooted trees. If you can imagine, we're going to be looking at anywhere between 3 to 5 feet of cover between different layers, and I want to avoid root penetration and getting into the tailings. So you will have sort of a shrub, a small tree growth, and grass on top of this thing when we're closed up.
Okay.
Yeah. Okay, so this area is sort of the entrance into the main guts of the mining and concentrating infrastructure, or the proposed. What we're standing on right now is sort of the boundary to lay down areas. So there's ore storages, waste rock storages, different overburden storages, as well as a cold storage for just equipment laydowns and that sort of stuff. So you can kind of get a good visual of the topography that we're sitting on right now. It's already relatively flat, so there's not a lot of groundwork that has to happen. Now we have talked to, and we've got soil scientists involved. You can obviously see that there's some depressions. We're actually on the boundary of a wetland as well. We've got in place sort of design inputs that we can use, as well as, we've already moved some of the infrastructure a couple of times in the conceptual design to avoid different wetlands. We're operating with 0 impact to wetlands around that have been delineated, so pretty happy there. So I guess what we'll do is we'll go for a little walk from here, and we're just going to walk down the route and get into where the concentrator building is proposed, and the portal, and the main infrastructure. Are there any questions around the laydown area and sort of what we're looking at here?
you know what the average slope for this area is?
It's a tough number off the top of my head, but I think the topography, not given this one specific area, but the topography is, I don't know, somewhere between 3 and 4%. It's not an extremely steep area. When we get down the hill to where the buildings and stuff are going to be located, it is a little bit steeper, but it lends itself quite well to the construction that we'd like to do. So. This area is sort of the guts of where the infrastructure would be. So you can see in this area there's a little bit more topography. It lends itself quite well to what we'd like to do. Starting with the mine portal. So typically when we want to develop a mine portal, we'd like to develop it into a hill, and then that way we can keep the footprint nice and small. Where we're standing currently is sort of in the center of where the concentrator would be located. So that concentrator is typically operated by gravity. So if you can imagine, it's a series of, there's a grinding circuit, but then there's a flotation circuit, which actually separates the metals from the gangue. What happens is it starts with a series of baths, and then those baths then deposit into another series of baths, and so they just kind of cascade. So having topography like this, our mill foundation would ultimately be sort of a stepped elevation foundation. So it's actually set up very well for that type of design. In addition to that, the topography is not so steep that we can't level pads for a warehouse, shop, and that sort of stuff. So it's actually a perfect little location for it. The drainage in this area, it's fairly shallow to bedrock, so the drainage in this area is fairly easy to manage. And once again, we're outside of any sort of wetlands, so there's no wetland impact there either. The infrastructure that's going to be here is, essentially it's everything. So the mine portal would be about 100 feet that way into the woods. As I said, we're standing on the concentrator. There would be a series of offices and dry facility here that would ultimately be tacked on to the side of the mill, the concentrator building. And those facilities are so when workers come into the property, they're able to shed off civilian clothes or clean clothes, and then go in and put on their overalls and boots and everything like that. So all of that is stored on site here. The offices are going to be able to accommodate management, technical staff, health and safety admin, etc., just everybody. Ultimately, the idea is that the site is fully supported internally by its own staff, and we're not going to have centralized locations in towns or anything like that. Everybody will be housed out here. I guess the other thing the plan is that we're going to have a bit of an active laydown area here as well. I mentioned one of the laydown areas on the other side of the wetland, but there's going to be another laydown area sort of adjacent to where the portal would be, and that's just to supply day-to-day activities for the mine. It would be something similar to the mill as well. So, any questions for this area?
I was going to say, on the plan it showed you're going to have like a mine ore hoist.
Yeah.
What is that?
So a portal is the opening to a decline. So a decline is basically minus 15% ramp. So you're kind of walking down a hill similar to this, and that's used for vehicle access, man access, etc. When we're talking about a hoist, so we're looking at options between truck haulage from underground. So we just load all the material into a low-profile truck and drive it up to surface onto a storage facility. Another option, in contrast to that, is a hoist.
Hoist is like an elevator, and it's used to haul broken material or ore up the shaft to surface instead of hauling it by a truck.
That way. Dumbwaiter.
That's 100% what it is. It's a very large dumbwaiter. Yeah. So, I mean, there are benefits and negatives to each way. So ultimately, what we forecasted so far is that we simply load it into trucks and haul it to surface, just because that's the most simplistic and easy thing to consider. But when we get into, again, the more detailed design, those are all different considerations that we'll be looking at for sure. Yeah.
So would you say that this is the steepest area that you're going to need to be working in on,
Yeah.
on the property?
Yeah, certainly. It is the steepest area, but again, when you're considering the topography, you're really considering drive access and that sort of stuff. The working platforms will still be flat. Yeah, and we can keep them sort of adjacent to each other, but they don't all need to be connected. We would never have to come in and sort of level a whole area like this. So we would try and mimic the topography where possible, specifically because upon closure, the idea is that we come in and we contour it back to the natural topography anyway. So we've flown LiDAR surveys. We know exactly what the topography looks like to a 1 meter or a 3 foot scale. So we have the ability to come in and recontour it when we close up the property, and that's planned for. So the less contouring we do to start out with, the less we have to do at the end of it. So the drifts, the tunnels that we drive underground, they're about 16 feet by 16 feet wide and high. The portal itself is typically 3 times wider than the opening of that, so that we can have room for, traffic management, running, services underground, etc. So the portal opening is anticipated right now to be anywhere between 32 to 42 feet wide by roughly 64 feet long. And that depends, we have to do geotechnical studies as well to find the right location for the portal. So there's going to be a series of core samples taken to identify the strength of the rock and the composition of the rock. And then once we find the right location, the topography in that area will really dictate how long that portal has to be. So this area, we're kind of sitting in the middle, or just on the northern ridge of the tailings facility. So this is sort of, where we're standing, we'll be depositing tailings here somewhere around year 4 to 5 of the operations where this would start. What I wanted to show here is sort of the topography that we're looking at. So you can kind of see the relief on either side. There's no major steep slopes or anything like that. So we have the ability to really come in with tailings deposition and mimic this topography quite well. I mentioned earlier that it's going to be roughly 22 feet higher at max upon closure, but even though it's 22 feet higher, still below the tree line, we're able to mimic the topography that we see currently, and that's how it's designed. So again, all of the precipitation, all the decant water that would potentially come out of the tailing is collected with that underliner system, and then it's drained off to the exterior of the tailings facility and collected. Then it's pumped back into the concentrator as processed water. So there's a small pretreatment, but what's important to note is that the water that comes in contact with the tailings facility doesn't all get collected and put through the water treatment facility. It's recycled back into the process. So a lot of the concerns around are we able to treat the water to the quality that we've indicated that we can? It's important to note that we're not treating all of this water. This water is actually used as processed water again. And you can imagine that the chemicals that are used through the process, there are still coated enamels over top of the tailings grains. And as those are drawn from the tailings, they're expensive chemicals, so we can reuse those back through the process. Any questions around this area?
From where we're standing here right now, Jeremy, where's the longest dimension? So what direction
So
is the tailings?
the long dimension is this way. It goes basically east-west.
What's the total acreage for the tailings facility?
So after everything is said and done, it's sitting at around 90 acres. I think it's 92, somewhere around there. But that's also designed with a little bit of additional capacity out of the mine. So we may not have to use every cell, but what we've proposed is this 90-acre area to accommodate for all the tailings that we're going to be placing.
Is there any kind of possibility of expanding it, for example, in the future?
So, so one of the discussions has been so far today that there is potential to expand the deposit. In addition to that, there are other satellite deposits around. So we have designed the tailings facility. There is room to expand it, but within the design specifically, we've already designed to account for an additional capacity over and above what we're currently planning in the mine. Yeah. So that's included in the current footprint. This is sort of our last proposed potential discharge point. This is the location on the very west edge of the tailings facility. So again, this is, just for reference, this is another one of those areas where after we collect and treat water that's been impacted from waste rock locations and that sort of stuff, it's collected, sent through a water treatment plant, and then it's pumped. And then it's pumped into an area like this that would have sort of a septic field. The septic field would then allow the water to kind of naturally seep back into the background, into the groundwater, both surface and subsurface. So this is the type of area that we selected. Topography is a big part of it, but also we're going to be looking for depth of bedrock and the surrounding soils and how they're able to receive that clarified water. Once again, I just wanted to mention that the water that is being deposited into these areas is treated back to or better than background quality. So, the risks around contaminated waters being discharged are very well controlled. And even before it goes into the water treatment plant, it's collected into a large pond. And then after it's treated, before it's discharged to the environment, it's collected into another pond, a clarified water pond. And that pond we're able to sample and ensure that the water meets discharge qualities before we open up a valve and allow it to actually come back into these areas. Any questions around that at all?
Do you know how big the ponds would be at this point?
So the ponds, so the surface collection ponds, they're all designed for the, I think it's 500-year 24-hour storm events. If I've got the number right in my head, it is 36,000 gallons, somewhere around there, or maybe it was 36,000 cubic meters. But I'll find out and confirm that actually.
Sure,
Yeah,
I was just curious.
yeah. But they're fairly large. Yeah.
How big is the disposal area that would be in this location?
So that's the whole thing, is where the design is still relatively conceptual. There is a lot of soil studies that have to happen before we can define what that size is. The conceptual design is roughly, I think it's 300 feet by 400 feet, and they're in several locations around the perimeter of the tailings facility so that we can really shed out the water. The idea is that we maintain that sort of sheet spread, and we're not localizing or keeping all of our discharge into one local area. But I guess to answer your question, we still have to do those detailed studies, and my interpretation of that is that's all going to come out of Chapter 200.